If you like my dad's videos, please subscribe to QA Insights channel.
Okay, I think yeah, people can hear you. Yeah, thank you folks. I don't know, suddenly my Clubhouse app crashed, so I had to restart, and it took me a while to come back. Sorry about that. Okay, so let us begin. I think we have wasted 10 minutes. That's fine. We can keep it short. Okay, so how many of you use Dynatrace, Neuralink, or any other tool daily basis? Anybody can pitch in? So who build your dashboards? I just want to have a few questions before we get started. So who built the dashboard, whether it's a DevOps team or SRE, or it could be, is it you or is it your team? So how you monitor, and who builds the dashboard? So any inputs?
Hey Naveen.
Siddha, I'm not able to hear you.
Is it okay now? Hello?
Not able to hear you, Sid, I guess.
Hello, Naveen?
Okay, Raj is saying in GCP, cloud monitoring tools. Okay, cool. Okay, you can also chat. If you don't want to talk, you can also chat. So there's a chat option here.
Hey Naveen, can you hear me now?
Okay, not able to hear you, Sid. I think there's a problem with the mic. Okay. So, okay, before we see about the dashboards, monitoring, everything, so let me give you an example, day-to-day life, right? So suppose you are driving a car, or you're operating traveling in a bike, all right? Or if you're a pilot, right, you operate airplane, right? So wherever you travel, or whatever vehicle you operate, so you will have a dashboard. So the dashboard will display all the vitals of your vehicle, right? For example, there will be an indicator for fuel, or engine is cold or hot, that one, and then a tachometer for speed, and then some if there is any issue with respect to doors or brakes, right? So tire pressure. So every important vitals you will see it in your dashboard, mainly in the car. And again, cockpit means you will have lots of switches, lights, colors, right? So these dashboards will help the operators, or whoever is operating the vehicle. It will give you some information about the condition of the vehicle while traveling, right? So suppose if you're traveling and there is a fuel is going to empty, fuel tank is going to empty, then it will display the respective light. Or if something is somebody is not closed the door, then it will displays the indicator. Or if somebody is not wearing the seat belt, after a few seconds it will give a peep sound, right? So these are the things which will helpful for any driver, so that they can safely travel and then they can reach the destination. Okay, similarly, so you bring that whole dashboard vitals to the dashboard. Your whatever the tool you are using, Dynatrace or Neuralink, whatever the tool, doesn't matter. So whenever you open your APM or observability tool, first thing you see is your dashboard for your application. So by default, many APM or observability tools, they will display their own way of displaying the information. For example, if you see Neuralink, they will display the response time at the top, and errors, logs, and CPU memory, everything at the bottom. On the right side, they will display some tracking, the history, anomaly detections. So everything they will display it in one single dashboard. So this will help us to see what's going on right now in our application, right? So this is how we operate daily. So as a performance engineers, we usually run our test and go to the dashboard and monitor. And for who are in production, DevOps or SRE, they always monitor. But again, it's not possible to sit in front of the dashboard every day, every time, every second. So they will have some kind of a alert system, right? So mainly I have seen organization, they use PagerDuty, or a Splunk also, they have their own tool. Or sometimes they'll put something very simple, HTTP endpoint. If something goes wrong, it will automatically send a Slack message to the channel, or sometime it will send a SMS or phone call. So based on how they want to build the this alerting system, they will just implement that. Again, it is not possible to alert everything, right? So that is too noisy then. So I have seen many channels, right? Channels, I mean, could be public channels, so you can see. They always send notifications, mobile notifications. So even I have set up for my own website blogging. So I use Lightstep. So Lightstep, again, they have their own way of alerting. So sometimes it is kind of false positive. Sometimes it will be truly down my blog. So I have to just log in and see. So most of the time it will be false positive, but it doesn't mean that my alert system is not working. Basically, I have to fine tune the alerting process. So these are the couple of ways people monitor in production. So on what basis they are building the dashboard? So that is the first question. So as a performance engineers, we have to know how to build a dashboard, how to read the dashboard. So somebody, most of them, we don't have exposure to the production, right? So production dashboard might be different than whatever you have right now. So in case, suppose if you're getting the access, so you have to read the dashboard and see what's going on and how to find the issues in a very short time, because human effort is very expensive. If something goes down, if you're getting paged, you have to find the root cause immediately, right? So the human effort is very costly. So it is our responsibility to get to know about everything in hand at before itself, so that you can deep dive the issues and find the you can find the root cause. So on what basis they are building the dashboard? To answer that question, if you go to sre.google.com, so there is a website. It's a Google SRE book. So this book, every performance engineer must read at least twice. So why I am saying twice is, first time if you read, might not be, might not get everything. Again, you have to read it again. So this book has a section called monitoring the distributed systems. So under the chapter monitoring distributed system, there's a section called the 4 golden signals. So this 4 golden signals is the basis for any dashboard you build. Even if you build today, you will be creating the dashboard based on these 4 golden signals. So the first golden signal is, of course, latency. So response time. So latency has a different term: response time, processing time, right? But everything is comes to the response time. So how long it is taking to get the response from the server after processing it. So here there is a catch actually. So HTTP 500 also will give you response time, right? Because it will be very low response time. So you should not consider the HTTP 500 response time. You have to consider only the valid requests and valid response time. Okay, because many developers, what they do, they send a 200, but in the error message they will say it's not processing, or some kind of error they display in the JSON payload. But our tool will think, okay, we don't check that message. Sometimes we check only for the HTTP 200, right? Explicitly, any tool, JMeter or load runner, they check only for the explicit error codes. So if it is a 200, it will display as a pass, and it will consider as the response time, and then it will skew your results. So you don't want that. So you have to properly catch the errors and properly bucket it, and properly catch the response time, and again display it in the dashboard. So you have to build a dashboard with latency. Okay, so this is the first golden signal. The second golden signal is traffic. So traffic is nothing but the throughput. Mainly it is a requests per second. So how many requests your system is getting, or hits per second your system is getting, and then you have to monitor mainly the RPS, request per second. And in case of video streaming or audio streaming, you can think of like a packets per second, or if you're testing some Kafka messages, right? Messages per second. So these are the various things you will monitor with respect to traffic. Depends on the system you are testing. Okay, so basically traffic means throughput. Okay, so we have seen latency, we have seen traffic. The third one is errors. So again, errors, as I already said, we have to properly catch the HTTP 400 and above. So 401 means unauthorized. So you have to properly bucket it. Again, 502 bad gateway, 503 service unavailable. So 502 bad gateway means service is down. So you can easily go to the service and then see whether it is actually up and running. 503 service unavailable. Again, service is it's fully loaded. The system is fully loaded. You cannot take any more requests. It is down. So based on the error code, again you can catch the issues pretty quickly. So you have to properly bucket it, and also make sure you are properly catching the 200 also. So again, this needs some kind of play around with the charts and graphs and queries, but eventually you will get the idea. So basically you have to properly catch everything and you have to properly bucket it. Okay. So latency, traffic, errors. And the fourth one is, it's kind of a very little bit advanced signal, saturation. So saturation is basically how full your system is, how occupied your system is. So mainly deals with CPU, memory, disk and network. So these are the four parameters. You will plot the graphs. For example, how full the CPU is, how many cores it's running, up and running, and then what's the memory utilization, what's the GC pattern, how frequent GC is happening, what is the disk space utilization, what is the network utilization. So these four mainly comes under the saturation. It's very kind of advanced graphing and metricing, but these four signals will help you to give some idea about how and how fast you can find the issues just by seeing the dashboards. Okay, and again you have to properly bucket. Bucket means, I say, percentile you have to calculate properly. Do not go for average, go for percentile, and then cardinality, and then again depends on the plan, depends on your budget. So everything plays an important role in building dashboards based on these four golden signals. Okay. So any questions, guys, for till now? So you can raise your hand if you are new here. Please raise your hand so that I can admit to the stage.
Hi, Navin. Can you hear me?
So you have seen latency, traffic, errors, saturation, LTES. So you remember these four terms. Okay, this is very important. Even it will be very useful for your interview also. And next we are going to see the methods. So what couple of methods are available, the strategy, we are going to see that. So before that, if you have any questions, please let me know.
Hi, Navin.
Sid, you are talking, but we are not able to hear you. Is others can hear Sid? What who if he is talking? I'm able to hear Sid. I don't know. Okay, I'm not able to hear. I don't know why. Can somebody come to the stage and check? I just want to validate my the cable earphone is working fine or not. Hey Rajesh, thank you for joining.
Hi Naveen, is it audible?
Sorry, I'm not able to hear you. Let me disconnect and connect again.
Naveen, I think it's an issue with your end. We are able to hear Sid voice. Sid, how about now? Sid, can you hear me?
Yes, Raj. I can hear you.
Yeah, I think it was an issue from Naveen's side.
Yeah, I can hear you now. Yeah, I can hear you guys. Thank you.
Oh, okay. Hey, Navin. Yeah, I think yeah.
Yeah, okay, thank you. So any questions, guys? LTES, latency, traffic, errors, saturation.
True, Navin. Somebody want to repeat it as well. So even they have some glitches while listening.
Okay.
And before that, I have an input. Please do cover whenever you say, I mean, like metrics like CPU, memory, network, disk level. So there are two kind of things always, like the server hardware level and process level, like JVM process level. Just to highlight that point.
Yes, yeah. That is the next method. We are going to see that only. So this is the basic fundamentals, right? So as Sid mentioned, right, there are two methods you can see if you Google. There is a use method, USE. Okay, it is created by Brendan Gregg. He is the performance engineer at Netflix. So this USE method, the use method, it stands for utilization, saturation, and errors. Okay, so these three parameters fully deals with the hardware level metrics. So at hardware level, they will fine tune the CPU, memory, disk, and the errors. So this is kind of very high level, but we will see whatever I can cover. So this is the first method we are going to see, and then we are going to see about RED method, RED method. So RED method is created by again the person who wrote the Google SRE book. So he was working for the Google, and he came, he resigned from Google. He joined Weave.works. That's the company. So he created the RED method. So this RED method is more for performance engineers, basically. I mean web performance engineers. So that deals with the requests. So it deals with the request rate, and then request errors. E stands for errors, and D stands for duration. Okay, basically the response time. So this RED method is mostly closed with web performance engineers, and USE method is mostly for the hardware performance engineers. Or even if you have interest, you can also deep dive into the use method. And we have, we means I mean at Salesforce. So we define a method called reads, READS. Okay. So this reads is for the microservice architecture, distributed microservice architecture. So this is a reads kind of a blend of thing. You can think both request rate. R stands for request rate, E stands for errors, A is for availability, D is for duration, and S is for saturation, right? So these are the three methods we are going to see today. Okay, so any method you aware apart from these three methods? Anybody?
Navin,
Yeah.
sorry to interrupt. Like before going to deep dive, that's good topic you are going to cover. Somebody asked to repeat the four signals you repeat. Just introduce.
Oh, okay. Sorry, I'm not looking at the chat. Sorry.
Because
Yeah,
of that glitches
latency.
happened, right? Somebody
Yes.
only
Yeah, L is for latency, T is for traffic, E is for errors, S is for saturation. Okay, so LTES, you can think of a LTES band in cellular, right? We have LTES, so you can think of like a mnemonic: latency, traffic, errors, saturation. So always response time will come in all the methods most of the time, except use method. And a traffic, again, it's about throughput. Errors, of course, you know errors. And saturation, mainly for the CPU, memory, and network disk. Okay, so first let us begin with use method. So use method, I came to know, I bought the book actually, System Performance by Brendan Gregg. So that's the book I refer usually whenever I have some doubts. So that book a little expensive. I'm not sure how much it is costing in India, but here I paid around $40 something. It's kind of expensive. It's a very huge book. It's kind of a Bible, you can say. It's a Bible or a Gita of for performance engineers. So Brendan is mostly he works on the hardware level performance. So Linux, and then he go to the kernel. So if you read that book, mostly kind of very advanced topics. Okay, so he explains this use method. So basically, it is for every resource. Every resource means your hardware, basically the server or instance. You can think of. You have to check the utilization, saturation, and errors. So this is the summary of a use method. Okay. So here the resource, as I said, right? If you have a system, you have CPU, you have disk, you have bus, you have memory, right? You have network bandwidth. So this is called the resource. So inside each instance, we have to take care of the several functional components. So this is what he refers as a resource. Then he refers the utilization as the average time. So he is talking about the average time of the resource is busy in servicing the work. For example, CPU. Okay, how busy the CPU is, that's the utilization. How swap memory, or how frequent the swap is happening, or how frequent the objects are allocating, right? So some kind of utilization. So this utilization graph we have to it has to tell the percentage basically. Okay, how much percentage it is busy, right? So this is called utilization. And saturation basically how resource how full the service is, basically how full the CPU is, how full the memory is, where it can't serve the requests. So basically how busy it is basically, and how often it is queued, how many what is the queue length. So those things under saturation. Again, don't think of anything about the request, or don't think anything from the web point of view. Always, whenever you see use method, think always about the hardware part. Okay, that is the main difference between the use method and other methods. And errors, as you know, how many errors you are getting. Okay. So any questions in the use method? I'm covering very high level because I don't work in hardware performance, but this is the method you should aware when it deals with hardware.
Yeah, not question, Navin. So yeah, I think if it could be clear. So guys, Navin is trying to cover from the hardware perspective, but we as a performance engineer, we don't dig into those metrics until we see any, server related issue.
Yes,
Generally,
correct.
we'll go for process, and most of the time, any response deviation or any errors, we'll dig into the server level. That is JVM or .NET process, whichever you are running on the server. But if at all, yeah, I do used to monitor with the nmon for the Unix metrics whenever there was a no, I mean, third party appmons tools are available. So at that time, we used to see like a swap memory, how the CPU, how the disk reads and writes, and how the any processes, any zombie processes, those kind of hardware level metrics that related to use method monitoring, which Navin mentioned.
Yeah. Yes,
Thanks.
basically use method is it's a tool or OS agnostic. Basically, it doesn't mean that only Linux operating system you have to use this method. So it doesn't mean that you can use it for Windows or other operating system as well. And it doesn't talk about any technology aspect like, for example, JVM, right? Again, it's technology based entity, right? For Java environment. That's what it doesn't talk about anything about technology or the operating system. So basically, the high level component, CPU, mainly the hardware, CPU, memory, and we can say kernel or Windows, whatever the core, right? So whatever you can think of for the each operating system. And again, threads, number of threads, CPU swaps, input output, disk write read. So these are the things it deals with the use method. So whenever you think about the CPU architecture, memory, whatever, cache, right? Think of use method.
Yeah, probably can be applied for even DB if you're extensively monitoring DB.
Yeah.
There could be,
Yes, correct. Okay, so this is about use method. Again, it's kind of a high level, a very advanced topic. It needs a lot of expertise. If you want to get a job in Netflix or like companies, right? They really don't need a web performance engineers. That's what I have seen from their career page. They always look for Linux experts, hardware level tuning, and then eBPF, Berkeley Packet Filter protocol. So those things only they will look out for. So they don't. I never seen anybody as a web performance engineers. I never seen any job posting from Netflix.
yeah. In the initial, I think when we were couldn't able to speak, right? When the discussion started, I think you were asking, does anybody created their own dashboards?
Yes, correct. Yes.
To answer that question, I mean, yeah, we do create our dashboards. Like we have already discussed only the process related metrics, JVM or .NET related metrics, not hardware related. And so do you follow any this methodology for this as well? The process
Yeah, I
related.
mean, I create my own dashboard.
Yeah.
So I don't follow these methods, but I mean, it's good to know, right?
Yeah. Yeah.
Because whatever you build, right, it will be based on either one of these methods. So it falls under the any bucket of these.
True.
So that's
True.
not necessarily you have to follow this, but whatever you need, if you build, it will be on top of this.
Yeah. True. Real. Yeah. Good.
But again, if you follow the process, whether use or read or reads, you will get whatever you need in very short time. Basically, you don't need to keep on updating your dashboard every now and then. If you build one time, you will get whatever you need. Then you can just fine tune your queries to properly display the details.
I think these high level methodologies will be covered by the providers when it comes into the cloud picture. So they will
Yes,
be.
that's what Neuralink Dynatrace. Everybody has their own dashboard, but sometimes it is not much useful. It might not give everything what you need.
Okay. Okay.
So in case say your manager is asking, okay, I need something very high level, then it will not be them, right? You have to create a new dashboard for them,
Yeah. Yeah.
right? Again, it depends on the audience who you are talking. They might need it has to speak their language,
True.
right? So you have to build the dashboard for that. Again, whatever you see, Dynatrace or Neuralink, anything, it's a basic built-in dashboard, right? You cannot change something. I want, say, instead of 95, I want 90 percentile. Then you cannot do that. You have to build a dashboard for that,
Yeah.
right?
Yeah.
And
Yeah.
I want to compare two different graphs, right? So it is not possible by built-in. It will always by a timestamp, and your y-axis will be your request per second or throughput or response time. I want to compare, okay, response time versus throughput versus time. So then you have to build a dashboard for that,
True. True.
right? Yeah, Grafana, again, it is very powerful. You can do a lot of things in Grafana. If you go to play.grafana.org, it's the demo Grafana dashboards. You will get a lot of ideas from their dashboard. It's very powerful, sophisticated. I mean, no need to replicate everything, whatever it's there, but you can take some inspiration, and then you can build your dashboard from that.
Yeah, I think Navin, you need to bring up another topic on APMs, especially because nowadays a few most of the APMs going towards observability. So, and also we would like to know, since you are come across the different APMs tools like Elk, Grafana, different things. I think it would be better if you can.
Yeah, monitor APM is gone. APM, the term is gone from all the vendors.
Yeah, yeah.
So I have seen Dynatrace many years, 7 8 years ago. Their homepage itself, it says APM. But nowadays, if you don't see APM in any vendors,
Yes.
so everything is observability, or it's a marketing term also
Yeah.
nowadays. But yeah, that is what it is. APM is not doesn't not exist anymore.
Yeah, I think it would be better if you bring up a next topic with on tools like monitoring tools.
Observability.
Yeah, yeah, yeah. That's what. Yeah, if it's distributed observability, and I think you can ask the questions from the audience. If they do have some questions, I guess.
Yeah, anybody has any questions, please raise your hand. So we have seen LTES and USE use. And if you don't have any questions, we can move with the RED method. Okay. So RED method designed by Tom. He's the creator of this method. So this is mainly for the microservice architecture and mainly based on the requests. Okay. So whenever you see red, it is mostly everything is about the requests. Okay. Request per second means throughput rate. R stands for rate, and requests, number of failed requests, errors, E stands for errors, and duration, what is the time amount of time each request takes. basically response time. So R for rate, E for errors, D for duration. So these three metrics, if you build a dashboard based on this, you can easily find the issues with respect to your service, response time and performance. So it doesn't talk about anything about saturation, or it doesn't talk about CPU, memory, those things, system level metrics. So it doesn't deal with that. It deals mainly from the microservice point of view, about the performance only the performance you will get it. Okay. So here again, if you search for RED method, you will get a lot of dashboards. Again, you can take an inspiration and then you can build it. And this method presented in some conference, I think GrafanaCon. So there only I saw the talk about the RED method. Okay. So I think he's the one of the author for the Google SRE book. So from his expertise, he brought this up for the microservice architecture. But again, this is kind of very, again, it's a kind of a starting point, I would say. Just using these three, you cannot find issues if with respect to CPU or garbage collection or backend, something is failing, like say database connection, right? So database is failing, connection is failing, then just by seeing the request, you can see, okay, request is high response time, but you cannot really pinpoint why it is high, right? So you have to deep dive, you have to follow the observability tool or trace, or if you have a knowledge, you can easily find, okay, where the issue is. So again, it will give you a starting point, I would say, but it's one of the philosophy you can also implement if something you need very basic.
I think Navin, the red method meant to be how your microservice scaling when the ideal situation is yeah, like you mentioned, it's nothing will give you what is a problem or potential problem or bottleneck in your service or anything.
Correct.
And coming to the microservice, it's very rare any microservice will interact with dev. It's like loosely coupled communication happen within across among multiple microservices. When the coming to the microservice into the picture, only a read method will be available as taken as a scalability point.
Correct, correct, correct.
Assuming that everything is perfect.
Yeah,
Yeah,
it's mainly for scalability, how scale the application, I mean microservices.
and availability.
Because we have Kubernetes nowadays, right? So Kubernetes auto scale, auto replicate, right? So based on these three, you can easily see, okay, how many parts are up and running based on the request per second, or how many nodes are up and running. So those things we can monitor. Okay, so any questions on the RED method? Okay, cool. So next, again, I'm going to touch base on the REDS. So this one I already posted a link in my LinkedIn. It got many likes and shares last month, I guess. So this again, we came up, I mean, not we means not my team, some other team in within Salesforce. So again, it is for the microservice architecture where you have some thousands. I'm not talking about a few tens or hundreds, thousands of architecture, microservices up and running in your infrastructure. Then how you can track, how you can find the issues, what are the indicators you need to pinpoint the issues. So that is why they followed the REDS method. So if you implement REDS, you will get a full view of at least 99% view of how your microservice is performing. So R stands for request rate, the throughput, and E stands for errors, A is for availability, and D is for the latency, I mean the request response time, and S is for the saturation. So here you can see it starts with requests and ends with saturation. So from the entry point, what is our entry point, until the backend. Backend means I'm talking about the resource utilization, CPU, memory and all. So everything you can catch by implementing the READS. Even it talks about the availability. So availability, as you know, whether your service is up and running. So there are multiple ways you can find it out. You can send some HTTP endpoint, and if it is a 200, it is up and running. or you can use some kind of synthetic monitoring where you can do some kind of an action, but it is very expensive, right? You cannot implement something like an automation. Of course, Dyna Trace Neuralink supports this, but it's kind of a very expensive operation. So again, they implemented availability also into the READS method. So mainly, again, whatever we saw, right, in case of errors, so you have to catch the failed requests and exceptions. So both you have to catch. And for the request rate, again, I have already told you the throughput, how many requests you are getting, and availability, again, how many operations per second we are doing, and what is the uptime. So that thing they will calculate. And then duration, of course, the response time, and saturation, again, the definition doesn't change. So how full your service is. So these 5 graphs, if you build based on these metrics, you will get some single pane view for your infrastructure. Okay. So we don't we use, I mean, many teams use Neuralink, but Salesforce also has their own monitoring observability platform. So it's already there in the article. It's called Kaiju and Monsi. We are building our own tools. Okay, so yeah, whatever I am working, we are moving towards the new platform, and we are following the reads method.
Hey Naveen,
Yeah.
I have a question on. Would you elaborate on the reads everything fine and every pattern? Definitely, error is one of the star pattern they are following in all the patterns. So, I think you have initially covered error. Apart from 200, you should only consider above the 500, right?
400, yeah.
Above 400, 400, yeah, yeah, yeah. There is a, I mean,
401 also we can see what's going. I mean, 404 not found means something is not there, right?
yeah, yeah. That's what. So my question is, somewhere you covered like for the response times duration, you should not cover the error scenarios, error
Correct,
one.
correct. Yes,
Uh,
that's correct. Yes, because if you're getting a response time for the failed request, it will be very low.
but the sometimes so timeout duration could trigger into the errors, right?
A timeout, I'm not sure
Yeah,
what is the
response
specific for
timeouts
timeout.
or connection timeouts, which could be I mean triggered into the errors. So server busy 5 or 500, it could be turned into 5 or 3. Server amenable.
Yes,
Let's say there is a number of connections got increased all of a sudden in the web container level. So connections out of connections, it may throw 5 or 3 errors.
yes.
So don't you think that will be considered as a response times? Uh,
That's what. So
Dash?
for example, for request timeout, right, it is 408. So if you can put, you can have to properly bucket it. So 408, how many requests are getting timed out? So why it is timing out, you have to deep dive.
Okay, okay. That point I missed.
Yes,
Properly
yeah,
bucketing.
that's what. There are a lot of error codes. You have to properly bucket it. Otherwise, it will give you different
Yeah.
opinion from of your service,
Yes.
right? So you have to properly take care of this. Not just we can don't put greater than 400 and get the errors and
Yeah.
calculate the exponent. So
Correct.
it doesn't make any sense. So you have to properly categorize.
Yeah. Thanks for elaborating on that part. Thanks, Naveen.
Best is you can do when the test is running, you can also simulate. You can just send the endpoint, you can see what's going on, so that you will get something very clear from your side also. So what you can do tomorrow, if you're going to, I mean, if you're trying to build a dashboard, try to build a dashboard without seeing any existing dashboards. Try to build a dashboard without referring anything, and just write what you need, how you want to display, what you want to display. Then build a dashboard. Then compare with the existing dashboards out there in the internet. Or if you go to Grafana, if you just Google sample dashboard, every vendor has their own dashboard. You can refer that.
Since you people are following the reads method, so is there any use case or test case scenario where you could able to find out the bottleneck or potential?
No, we just started actually.
Oh, okay.
We are just moving towards our own market, our own tool. It's not completely implemented.
Oh,
Slowly
gotcha,
we're doing.
gotcha.
Yeah, probably in 6 months down the line. Yeah.
So bringing up the topic, so you do tested with the Tricentis and everything in Amazon. You have run couple of tests and last mile load test and everything, right? So what did you also? I mean, monitor their resources or metrics, Naveen?
No, we have, when I was working Neoload, it is on-premise.
Okay.
So nothing on cloud, because most of the enterprises, right, they are not fond of cloud-based solutions. I mean, they will opt for some solution, but they host on-premise.
I
So
think
on, yeah.
you are now. I mean, Shravanti, somebody. You people run last mile load test with Tricentis and
Not
I mean,
Tricentis, like the here Neocortex.
Neocortex. Sorry.
Neocortex, yes. Again, Neocortex. I don't think they will display very sophisticated dashboard. I never can't remember think of it.
So no
It
monitor.
displays graph and charts, but not. I don't think I have seen something like CPU memory.
Oh, okay, okay. Thank you.
I have to double check. I'm not sure. It might be in recent versions. They might be. I don't know. Hi, Dev. Thank you for joining.
हाँ, आप सब कैसे हैं?
Sorry, I don't know Hindi. You have to talk in English.
अच्छा, तो कोई नहीं, मैं जाता हूँ, लीव यू।
I think he's not related with performance group. Somebody marketing guy.
Oh, okay. Okay, Raj is raising hand. Let me admit. Hi, Srinivas. Okay, Raj is asking any reference to find different error code to bucket them. So it depends. You have to write some query, Raj. For example, if you're in Grafana, right? So you have to write respective query to display the error codes. So you have to write it. I don't think by default it will not have anything. But APM tools, or sorry, observability tools, Neuralink, Rantis, they will display the error codes. But if you want to be very specific, you have to write your own query. So different error code, you can HTTP, you can just type HTTP error codes. So whatever greater than 400, it does an error code from HTTP. Okay, starting from 400 and above. I'm not sure. I'm not able to admit Raj or Srinivas. I'm not sure why it's not accepting. You can put it in the chat.
Yeah. Shall I give my 2 cents to Raj and Naveen?
Yeah, sure.
Sure, Raj. So the buckets, right? The status codes, error status code, and bucket information. So it is always better to discuss with the developer. So sometimes they do consider few. Error codes like 207 or 400 plus as well, under 500. They do consider those as valid scenarios. So they are the best persons to give what your application, what are the accepted error codes are not upset. So based on that, you can build a dashboard.
I have sent the invite, Raj. You can accept to speak. Similarly for Srinivas also I have given. So please look out for the notification. You will get the notification. Sid, can you accept? Can you invite someone?
Yes, Srinivas, he was there. Here now, yep.
I made you as a moderator. You can invite Raj. Hi, Srinivas. Thank you for joining. You can speak now, Srinivas. You are muted. Srinivas, are you there? Hi, Raj. Thank you for joining. Yeah, you can speak now.
Raj and Srinivas, it
You
was
are on mute.
no. Even though they are unmute, it was same thing was with me. Just what you people do is like try playing around with the mute button. Sometime it will get you allow you. So it was happened with me same.
Maybe Clubhouse is taking more
Yeah,
load.
I think you need to do the performances for Clubhouse.
No, it's not my
Yeah, it
cup of
needs to be
tea.
performance system.
They don't have a web app. They have only mobile app.
Yeah, but only today. I think they are joined, but yeah. Uh, Sometimes never. Alright.
Hey, Raj. Okay, guys. I think there's some issue here. Yeah, please contact me in LinkedIn, or you can just put it in the chat. We can discuss. So others can drop off if you have other things to do.
I think somebody asked Naveen percentage of errors or Srinivas or somebody.
What is acceptable? Okay. So again, I don't see. Usually, I don't put any number on the errors. Everything should pass. So that is why my way of thinking, because not even one customer should not see any issues, right? So 100 percentage success should be there. 0 percentage of errors. But sometimes architects they will give some percentage, 0.01 or 0.001, something like that. So they give some number, they will just take some trade off, right? So you cannot put some number as a performance engineer, because we might not know about the business, we might not know the internals of the system architecture. So it is always best to get a word from the architects.
I think Raj want to share his knowledge on GCP monitoring, which he started. I re-invited him. Let's see. Yeah, Raj, can you try to speak now?
Okay, I made you as a moderator, Raj. You can also now can try. Okay, I think there is some issue really. Okay, guys, so fine then. We can talk, Raj, offline, probably, or if you ping me in LinkedIn, we can talk anytime. Thank you, guys, for joining. See you next week with a different topic. Thank you. Happy weekend.
Okay.
Bye.
Bye now.
If you like my dad's videos, please subscribe to QA Insights channel.